Hello, boys and girls. Today is day 2 of the week following. No, I'm sorry. Tomorrow's Wednesday, so I'm on Tuesday, and this is for tomorrow. So, day 3. Wrapping up this week with just applying the quadratic function to a lot of different areas, and today's gonna be more focused on vocabulary, just so that you guys see words in today's work and in future work, and you don't get confused knowing how they all correlate with each other. So first things first, you're going to see some language in today's work, and also in next week when we're starting the book. Turning point is the vertex, and we've spent plenty of time going over what the vertex is. When the A is positive, the vertex is a minimum. Remember, that means that the parabola opens up like that, and that's the A is. Remember, when I'm talking about the A, I'm talking about ax squared plus bx plus c. I'm talking about that coefficient in front of the x squared term. And when the A is negative, that means the vertex is a maximum. That means that the parabola opens down like that, and it goes like such. Other order business, axis of symmetry. You'll be seeing this all over the place in questions that are in the book, in today's work, on Khan Academy, future math tests that we take. Just, I want you to understand, all axis of symmetry is always, always, always the x coordinate of the vertex, and the equation is always x equals whatever the vertex may be of the x coordinate. And another order of business I want you guys to know and understand, when you see a question about the roots, the zeros, or the solutions, and this is particularly to quadratics, they all mean the same thing, okay? When they ask you for a root, they're asking you for what is the solution. When they're asking you for a zero, they're asking you for what is the solution. Again, where the quadratic crosses the x-axis, that is where you have a solution or a zero or a root. And they're called roots because sometimes they're not always clean looking numbers. So that's why you have to be, and some of you saw that in today's work, that it would not get outside the radical, so leave it in radical or root form. So I'm going to do just a couple examples because today's work, whatever. Wednesday's work is, just brushing up, doing some review, making more sense of this, solidifying that, and also some Khan Academy. And then we'll be diving into some word questions for Thursday and Friday. And then starting next week, we will start in the book where you'll follow along, and hopefully it's going to be smooth sailing. But again, this is high level math, so just take your time and ask questions. So that takes care of that. So first thing I'm going to do with you guys, and again, this is going to seem like a rather quick lesson today because I think you guys, based on the Zoom lessons, are getting the hang of this. And if you're not, please show up or email me, let me know what's going on. Let's start off with this. Let's say I want you guys to find the quadratic whose roots are -6 and 2. For something this basic, without giving a graph or anything, you can just assume and go right into, I got x plus 6 times x minus 2 equals 0. I know these make this true, so I want to find the quadratic. Carry our FOIL. We got x squared minus 2x plus 6x minus 12. Your final answer is x squared plus 4x minus 12 equals 0. And that would be good enough. Again, just wrapping your head around this terminology. Next thing, I want to graph a function. And this is more or less just review. Like I promised you, this is going to be easy work, hopefully. And if not, come and see me. If I have a question like this, y equals x squared plus 6x, and I ask you guys to graph this. Well, in order to graph this, I have to have the vertex, and once I have the vertex, I'll know my axis of symmetry, and hopefully it's all coming together. And then when I know my axis of symmetry, I can find 2 points on both sides of that vertex to help me make my intended shape. So let's put this in vertex form. So I go y equals x squared plus 6x. Half of this squared is 3. 3 squared is 9 plus 9. I brought a 9 in. I take a 9 out on the exact same side. Remember, we're not solving. We're using this in vertex form. So now this is y equals x plus 3 squared minus 9. So my vertex here is going to be opposite of this, whatever this is. -3, comma, -9. Okay, so I'm going to do my graph over here like this, and again, we're using point testers to help me graph this. Okay, so I got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Bear with me. So I'm going to test a very easy point, and I can test it in here, and here, or in here. And I'm going to test it in here just because it looks like it's a little easier. Easy point to test is always that when x is 0, find that y-intercept. So when x is 0, y is 0. And remember, the axis of symmetry, I'll abbreviate that, axis of sim, which we know is symmetry, is going to be the x-coordinate. So that's x equals -3. So that means, again, your axis of symmetry, if this point is 3 away from here on this is why graphing parabolism is not that hard when you think about this. When it's 3 away from here, it's also 3 away from here. So now I know, and I know this is true, and I can use my math. When x is 1, 2, 3, 4, 5, 6. When x is -6, I bet y is 0. -6 squared is 36. 6 times -6 is -36. 36 minus 36 is 0. Math proves it true. It'll always work like that. And it's a nasty looking parabola, but I'm not paid on my drawing abilities. So get used to it. That is that. Now, another question you guys will be asked about this today is, is this function, is this equation, is this situation a function? Do not forget about the vertical line test. Vertical line test, if I can put a vertical line anywhere on this graph, and it only touches the graph once, it is in fact a function. Remember, we did this before spring break. For a equation to be qualified as a function, one input must have only one output. If the vertical line crosses the graph at 2 different spots on the exact same x input, therefore it's not a function. Remember that. The other question for you today is about domain and range. So domain, think about this. I know your graph looks like you're going to stop really going out that much further on the x-axis because it's like it's veering up and going straighter, and I get that. But again, ask yourself this. Can you put any number in place of x and get a valid answer? And the answer is yes. All right? And this graph proves it true that this graph will continue on forever and ever and ever in both directions. Therefore, your domain is -infinity to positive infinity. Pause. Hey, you going to bed? Got a kiss? I'm in the middle of teaching a lesson right now. Okay? I'll be up and I'll say goodnight to you in just a minute. I'm almost done. Range. I'll be up in a minute. Now your range for this exact same graph, again, domain is your x values, range is your y values. So I'm looking at my horizontal for the domain, I'm looking at my vertical for my range. My graph will go no lower than this minimum, no lower than this -9, okay? But it will go up forever and ever and ever and ever. Therefore, it's -9 to infinity. And that would be sufficient enough to show me you get the hang of this. For the most part, that's about it. But I will do one more quadratic graph just to make sure you guys get the hang of this. So let's do one more because I heard today completing the square was still kind of a little confusing. So I do not know how this particular example is going to work out because I haven't done this yet, but let's just check it out. I'm going to do y equals, let's just say 2x squared plus let's say 4x plus 8. Does that seem reasonable? Nah, we'll do this. We'll do plus 3. Because I don't know what's going to happen. So I'm keeping my numbers low. So, first things first, if I'm doing this, I did this one on purpose to have my coefficient be larger than 1 so that I know this was some of your questions. So, y equals, divide the 2 out of just these first two terms. So this is 2x squared plus 2x, open parentheses, leave this guy outside, okay? Half of this squared is 1. Well, half of this is 1. 1 squared is 1 plus 1. Remember, I brought not a 1 into the equation 2 times. When I brought a 2 in, I must take a 2 out, okay? So now, and will this work? This will not work. So I just realized this is not going to cross the x-axis. Well, whatever, let's still do it just for grin so you guys see exactly what this is going on. So y equals 2 times x plus 1 squared plus 1, okay? So my vertex is -1, +1, okay? You'll see what I mean by it's not crossing the x-axis, and I know how it's not, and I'll show you what I mean by that in just 1 second. How I was able to see that so far ahead of time. All right, so now let's solve this because I don't have to solve it. Let's just try to graph it. All right, let's graph it like I did before. I just want to follow the same suit. If I got -1, +1, okay? Let's go here. And -1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. My vertex is -1, +1, so I'm right here. All right. And I'm going to go back up to this equation because this says too much stuff going on down here. When x is 0, y is 3. 1, 2, 3. So remember, my axis symmetry is that x right there. And if I'm 1 away this way, 3 up, I'm 1 away this way, 3 up. So I was trying to do a parabola that was going to cross the x-axis, but instead I did something different, which is probably good for some of you. This quadratic has no solutions, has no roots, has no zeros, because this quadratic does not cross the x-axis. Now, if some of you are wondering how I was able to figure that out way up here, because this, if I were to solve for this, and again, this is maybe a good mistake on my end, because we were getting some answers like this in today's work. So if I wanted to solve for the roots, solve for the zeros of this quadratic, I'm just going to use this, or not this one. I'll use this one right here. And I'll replace y with 0, all right? 2 times x plus 1 squared plus 1. I'm going to subtract 1, subtract 1. -1 equals 2 times x plus 1 squared. Divide by 2. I got a negative number. I got -1/2 is equal to x plus 1 squared. Okay? Now, down here, let me make sure you guys can see this. If I were to continue this like we have been in the past, I would then square root both sides, and I notice I'm taking the square root of a negative number. Therefore, this will not work. This is called, of the quadratic formula, the discriminant. So remember we did the quadratic formula? We got b squared minus 4ac. And you guys learned if you guys have a negative number under the square root sign, then you would not have any solutions for this. And again, the more you practice this, the more you're going to see that. But again, we can still graph this. And although this has no solutions, this is still a function because this still passes the test of the vertical line test. So all things considered, you guys will be doing just 2 worksheets today along with a couple Khan Academy assignments that I just tie it all in. I'm thinking the worksheets are going to be kind of simple for you, but you might get hung up on some of the vocabulary, so just come and see me for questions. I want to leave some of it to be a little mystery for you, but I think you guys should be more than okay. I will see you guys tomorrow.